So you're going to tell us why Siri's wonderful and why she sometimes doesn't, or it doesn't meet our expectations. I'll just note that I've been told I'm not allowed to say it, that everybody expects you to refer to Siri as she, even though it is just a piece of software.
That's right. It turns out that we can show, or our lab hasn't done this, other labs have shown this, that when you hear a female or male voice, even if it's obviously synthetic, which Siri is not recorded, our brains immediately say that's female or male, and as a dichotomy, not as a continuum. So what's great about Siri is people love to talk and even more love to be understood. There's nothing nicer than being understood. And the fact that Siri, to a remarkable degree, does that is fantastic. There are a couple other really, really clever things that Siri does. One is, unlike the Microsoft Paperclip, where if it doesn't understand you and you type the same query again, it gives you the exact same answer again. So if you type the same thing 10 times, it will answer the same way. Whereas there's a norm in social life that if I ask you the same question twice, I mean I should get a different answer. Siri actually does give you a different answer. Siri also uses humor. And people praise Siri as having, being able to tell jokes. It turns out we actually did the first study on humor in interfaces and showed that, in fact, successful jokes work. They make you seem smarter. If you're funny, you're smarter. Interestingly, even unsuccessful jokes don't hurt you. So if you tell bad jokes, you're actually not seen as dumber, as long as you're seen as cooperating and helpful. So when we put jokes in the Microsoft Paperclip, it was hated even more. But when Siri tells jokes, it's actually extremely popular. Another issue with Siri is it has a female voice in the U.S., a male voice in Britain, and different, I don't know all the genders in the other countries. The idea is in the U.S., Siri is positioned as a secretary or smart assistant, and in England, it is positioned more as a knowledgeable colleague. And that's why, again, the stereotypes were chosen. Barbara, why don't I turn to you to talk about a little bit about the mental modeling part?
Yeah, one of the issues that has been brought up to me repeatedly by people is, well, Siri can find X, but it can't find Y. Why is that? And one of the challenges, I think, for making systems, and Siri, I think, has really hit the sweet spot, is that once people see that a system can do a certain behavior, they assume it can do a whole range of other behaviors because any person who could do one of these things could do all of those things. And then you come up against the wall and discover that even though Siri knows where to find every drug in the world, it's clueless about where to get medical procedures done. Or you discover that you've asked Google, just to change slightly, you've asked it to do a search and it's absolutely brilliant, and other times it brings back the most ridiculous responses. So I think that that's really, that one of the issues, and this is, I think, a question for me in terms of educating the public and educating our students, what do you teach people about what systems do? Not how they work in their nitty-gritty detail, but what they do. So an example here would be if you understand that how search engines work is essentially very syntactically. Every word in an article looks exactly the same to a search system when it's indexed. So the search actually takes part in two places. First, there's massive indexing of all the documents. So that's done behind the scenes before you ever ask a question. Then, with the exception of a few words, essentially the closed form words, the function words, prepositions in articles, the, of, and so on in English, every single word in an article is indexed. Now, then there's very clever work done in figuring out about which words are more important in an article than in any other, but it's not based on the meaning of what's in an article. So then when you ask a search query, if things have been indexed well, you get what you want. But sometimes what you want is off on a side path that makes that indexing not work. So I think there's a real challenge as system designers, but also to people as consumers, to understand enough about what it's computing, not necessarily, as I say, how the program itself works, to really not expect something that's a toaster to make grilled cheese, basically.
And I think another important point about Siri seeming intelligent is Siri, when she speaks, or it speaks, doesn't come up with a sentence all by itself. It has very standardized canned forms. But what they did that was very smart was they used multiple standardized canned forms. Truly generating language, truly coming up with new sentences is unbelievably hard. My favorite example of this is, to this day, no one has come up with an account of how to use the word "the" in English. Even though by the age of 2.5 or 2, no English speaker screws up "the," you cannot actually teach someone who hasn't grown up with that all the different ways to use "the." So rather than Siri making wild guesses on when to use the or not, it's all structured and built in. So by making the system easier, but at the same time using tricks like using multiple grammatical forms that are all canned and built in, it actually makes Siri seem remarkably intelligent, remarkably fluent, when in fact it's not very fluent at all.
So we're going to switch to a different topic, which is I'll say what the problem is first and then what its manifestation is. Copying is easier and more intuitive than stepping back and remodeling and designing. So often when people take something that has been a paper process online, what they do is directly copy the paper process. I'm sure you have all been subjected to this. The first time that the Radcliffe Institute fellowship applications were put online, that's exactly what happened. They took the fellowship application book and they put it online directly. So where you had to turn a page, you had to go to the next page. There were separate applications for the sciences and for the social sciences. Instead of just being able to click a button, you had to... nobody ever saw that application because we made them redesign it before it went there. I understand from Cliff that when the proposal process was put online at Stanford the first time, they copied the paper process. Every single piece of paper that existed before now became a separate computer form. As I'm looking at health informatics systems, some of them do that. Not all of them, but some of them do that as well. So it's a real, I think there's a cognitive challenge here for the designers to make a break, but I also think it's important for anyone who's a consumer of these systems to realize that you need to ask people to step back and think about what it is you're trying to do. This is where, in fact, you can go back to the shared plans model and see that what you ought to be doing is thinking about what the work process is, what the workflow is, what computers can do well and what people can do well, and dividing up the labor appropriately as you design a completely new system to to gather the information or to have this interaction with people. As I thought about this, I realized that, of course, people for many years tried to build flying engines by having them flap their wings. And it's only when they stepped back and thought about the aerodynamics that we built airplanes that fly. And it's really a similar kind of thing going on here.
It's also an interesting issue in the way design is done, right? So what happens is a lot of design is done by taking a specification. And what people do who know a process, they spec out the process and say, here are the steps of the process, and then they say, implement this process. And as a result, the guys who are implementing don't have any control about making things easier, and it's partly an ignorance problem. It's actually hard to know what computers can and can't do. Even if I was a computer scientist a long time ago, and I don't know now what computers can and can't do. So to design successfully, you can either say, well, look, this is a process that we know works because it worked with paper, so let's just do it again. And then if you say, well, instead, why don't we just have the computer, why shouldn't I just be able to tell the computer this is what I like or what I want, and the computer does everything. And so I think this issue of mental models is a really important one. We're encountering it now with cars that get smarter. So cars are a scary domain like medical because you have to make instantaneous decisions. And one of the things that all the car companies are worried about is if your car can do some things really, really smart and other things dumb, well, you sort of get in the mode of, well, if it's good at this, it must be good at this. Like, you know, if it knows how to stop when it sees this, it must know it should stop at a stop sign after all. It's part of stopping, isn't it? And, of course, it doesn't. No cars read stop signs right now, so don't do that. But but kids do, right? So when you're teaching a young driver, you go, see that red thing called stop sign? That's one of the ways you stop. You also stop when there are big things in front of you. Not a big problem for drivers. I mean, they may have other problems, but not that one. So I think this issue of how do you build a mental model or an understanding, often in times when you don't have a whole lot of time to contemplate, becomes really hard. And the second problem is this idea of following what worked or whatever. We had the same problem in the Stanford grading system, which was based on paper, and it's just a nightmare.
So I think we'll throw it open to you now.
Yeah.